to the video lecture for that day. So if you like to watch this kind of stuff on the video, if that's helpful to you, it'll be there until I run out of space on Google Drive. So it's there for you. Okay, so we have some pretty modest objectives today. I do definitely want to get, it's actually somewhere around here. I want to get to that Git, the GitHub, and give you just some basic instructions, because this is going to become something that you memorize over the coming weeks, but it takes a little bit to get going with it. And the sooner you do, the more comfortable you'll be. So we're going to talk about what is a web application. We're going to talk about the various occupations, disciplines within the wider discipline of web development. There's many. We'll talk about the cloud, a new spin on an old idea, version control. That is Git. That's what we're going to be using. So for those of you who worked in engineering industry, do you use SVN or anything like that? Nothing like that. Okay. Different ways to manage different versions. We'll talk about sort of the open source philosophy. This is where a lot of opinion comes in. And we'll talk about how we're actually going to do this. We use a wonderful service called Cloud9, and that kind of brings together all the tools that you need, and it makes it consistent so that it's easier to teach you guys. So, a web app. What's an app, first of all? Anybody just tell me, what's an app? Application? It's a program. Would you say that there's a difference between a website and a web application? I'm fully aware, yes. So a website never changes. It's kind of true, right? This is kind of something that's getting blurrier and blurrier, because there's a lot of utility in static sites. They're very efficient. And if you're a blogger, for example, a static site is what you're going to want to do. Dynamic, it changes from visit to visit. So again, this distinction is getting blurrier and blurrier all the time. But if you go to the homepage of your favorite news aggregator or something, that information is constantly updated. This is the kind of thing that you need to sign in for and create an account. You're going to receive information that's custom tailored to you, even if it's only just reading your profile information. That, in a nutshell, is the difference between a web application and a web app. I might go a little bit further in that when you're designing a web app, you're also typically writing code. Not necessarily original code, but executable code. A static website does not require that. So now I'm starting to use a bunch of different words, like static, website, application, backend, front end. Sometimes I go too fast. Is this anything? Are you guys familiar with these kind of terms?
It's front end and back end.
Front end versus back end. The front end is everything you see in the browser. So the buttons you click on, the forms you fill in, everything, that page there is the front end. And the front end is built with certain technologies. When you're talking about this Lighthouse Labs, or this is GitHub specifically, you interact with it much more like you would interact with traditional software. Whereas the static website is delivering from the back end on a server. Back end is where the server lives. It delivers content to the front end, and the front end renders that content. Going further with web applications, there's much more of a two-way street. The user dictates to a certain degree, beyond clicking a link, what information is going to be delivered to the front end. So a lot more requests going back and forth. The back end is where that server's receiving these requests, saying, okay, well, what kind of request is this? Did you present the right credentials? Okay, yeah, looks good. I'll check the database, give it back to the front end, which delivers the content to the user. Is that still too much? It'll become clear. It'll become clear. That's okay. And if you know, and I said I maybe put too much stress on keeping up. If you feel like you're a little bit behind, that's okay, because even at this introductory level, this is still a challenging course, and it's a real education. This is not just something you sign up for on like Code Academy or something like that. Okay. So further to the front end. Traditionally, the front end has always been made of these three core technologies. HTML, I'm sure most of you are probably familiar with this. Anyone tell me what CSS is? And what does it do?
It makes your website prettier.
Exactly. So HTML stands for Hypertext Markup Language. I don't know why it's hyper. I think that was just trendy at the time. CSS, cascading style sheets. So I often reach towards sort of a home construction type of analogy. This is very much the frame and the foundation of your website, not necessarily a web application. This provides, the studs in the wall, provides some drywall and maybe some primer paint. The CSS decides on the paint colors. It decides on, stippled ceilings or base molding or anything like that. That's what I always reach towards. JavaScript is this is the executable code on the front end. Traditionally, JavaScript has always been a front end language. It runs inside the browser. So I'm trying to just stress these terms over and over again. The browser is the front end. JavaScript code is executed in the browser. This is kind of like, I don't know, your home theater system or something like that. Maybe the electricity or the security alarm. This is kind of what this makes a static page, makes it electric, makes it dynamic. It changes the stuff around. These three working together are the core of web development. As presented here, this only takes place on the front end. In the browser, when you type in a URL, make a request from the server on the back end, bring this information to the front end. It'll deliver HTML, JavaScript, cascading style sheets, how your site looks, how it's structured, and how it behaves. Any questions about that?
So they all work together, they're not
Yes.
separate things.
Yes. And it gets worse. This is just the front end. It's just going to get deeper and deeper, and there's so many components and so many moving parts. And you saw that disassembled camera on the previous set of slides. That's not an exaggeration. It's to do this, you have to have a very broad level of understanding. So the back end, this is the stuff that is not immediately visible. This is what the front end is talking to. When you press the button, the front end is sending a request of some kind to the back end. The back end looks at the content of that request, and depending on how you designed your application, you guys are going to be using a framework called Sinatra, writing programs in Ruby. Depending on what your Ruby code is designed to do, it'll take this information and behave accordingly. So this all happens on the back end. Front end browser makes a request to the back end server. Web framework, if there is one, receives that request and behaves differently depending on the contents of that request. Any questions about that? Okay. So another critical back-end component. So we were just talking about the web application, that web framework, Sinatra and Ruby. Sinatra, by the way, is, a Ruby program. It's written in Ruby, and you write more Ruby within the bounds of this framework to create a web application. Very few applications in computing anywhere. I'm trying to think of some exceptions. I think it's probably safe to say, like, for the last 3 decades, a database is usually an integral component of any sort of application, be it on the web, even be it on your phone. This is how we store data. So if you have all your user sign-up information, your emails, your passwords, we encrypt those so nobody can see them. We store them in the database, and every time the web application needs to know something, it consults the database, finds that information, and if appropriate, returns it to the client side. Client side makes a request, maybe the user signs in, goes to the server side on the back end. The web application says, is this password, does it match the one in my database? The database returns the password. Is there a match? Yes. Okay. Render this new page. Or no, redirect, give the user another opportunity to log in. Front end, back end, database, front end. Yes. Questions? Is this overwhelming? Or is this just usual stuff? I get a lot of different skill levels. A lot of engineers, every now and then a computer scientist. Is any of this familiar? I know we had some SQL expertise. Okay, I will continue. Please don't.
Programs like SQL and SQLite, they're related, or they're just different entities, or
SQLite or SQLite, whichever you like, is an actual database. SQL is a declarative language. So you tell a database with a little computer program the data that you want to retrieve. You pass that query, SQL query. The database runs the query, returns the data. So SQL, this is Postgres SQL. Anytime you see SQL, it's not exactly a totally standardized language, but the fundamentals are usually the same. So you can make the same query to a PostgreSQL database as you would to an SQLite database, and you would retrieve the data.
So is it safe to say they were like related if they're? I know there's Ruby and there's Ruby on Rails and there's Git and GitHub, but those are different.
Well, those are, yeah. I mean, we'll talk about Git a little bit more. Ruby on Rails is the same as Sinatra. It's a web framework. So your guys are going to be working with Sinatra. Ruby on Rails provides the same functionality as Sinatra, but Sinatra is much smaller. It's a Ruby program that receives requests from a server, processes the information, and allows you to modify the behavior of that application written within the Sinatra, written in Ruby on Rails. So these are good questions. We're talking about back end. We've even named them here, Sinatra and Rails. So the client, front end on the browser, submits a query or maybe enters a username. It's Sinatra and Rails that are going to receive that. I should say Sinatra or Rails.
So are these like collaborative, or are they independent?
Collaborative. Ruby is collaborative with Rails. Ruby is collaborative with Sinatra. Ruby is a language, right?
So they're underneath the Ruby.
Yes, in fact, they are written in Ruby.
Okay.
Yes. So these are two Ruby programs, Sinatra and Rails, that give us all the basic functionality of a web framework. Again, not really a standard, but just things that have emerged over time. Ruby just so happens to be the language that both of these are written in. For these kind of applications, Ruby is a beautiful language. I don't want to go too far afield, but you can also get servers written in JavaScript. Well, that's not quite true. Yeah, okay. Let's not go down there just yet. Okay, so any does that satisfy your question?
To a degree, yes.
Okay. All right. So yeah, we were talking about the relationship SQL to PostgreSQL. It's like Ruby to Sinatra or Ruby to Rails. SQL is a language, sequential query language. Postgres, SQLite, MySQL, all database management systems to which you submit these queries. Okay. Okay, so now we're getting to the part where you actually need to get your website onto the server so that people can go on their phone, type in your URL, and interact with the application that you've created. We use, for your purposes, a service called Heroku, which is free. It's a little bit lightweight, but I mean, if this is a serious issue, there's always ways to upgrade that service for a price. What this does is it takes care of that hosting. It puts all the content that's going to be delivered to the client side, all that HTML, CSS, and JavaScript, stores all that up in the cloud, so to speak. It also hosts a database, and it also hosts your web application, that Sinatra application. So 3 things are up on Heroku, and we'll show you how to use this. This kind of comes towards the last end, but I think we're going to cheat a little bit and just introduce you maybe in week 3, I think. So it's kind of using the generic term server. I think that's fair in the sense that any computer can be a server. But it does a little bit more than that. The server that it provides brings together all these components. It brings together the front end, the back end, and the database as part of the back end. Okay, so different disciplines. I describe myself as a full stack developer. I can do the front end, back end, and I can do all that deployment stuff. But you can make a very lucrative career just specializing in any one of these layers. And I mean, it's got 1, 2, 3, 4, 5, 6. Those are 6 very broad layers, and there's an ever refined degree of specialization within each of these opportunities, or in each one of these sub-disciplines. So the full stack developer will develop the front end, back end, database, and deploy it to the web. The specialist is just going to do the front end, for example. Just going to do user experience, if that's a term that's familiar to you. What the website looks like, how it feels. This is not just pixel pushing, this is serious programming. And you use those technologies named really early on: JavaScript, HTML, and CSS. Then there's this browser layer. Someone actually has to write the browser. I don't know anything about the browser, so I guess in that sense, I'm not a full stack developer. I just kind of trust that there's people who love doing this kind of stuff, and they do. I mean, where would we be without Chrome? Server side. I kind of prefer the server side. This is, it's mission critical stuff, but I don't really have the talents to make a visually appealing front end, for example. So I usually find myself quite satisfied on the server side. Then there's the web server. So this is just another piece of software, right? So many components. Picture that camera. The server is what brings us all together. Kind of, right? So much ambiguity until you actually sit down and do this, and this is what you're here for. This doesn't really become clear. You can look at this rainbow and really not have any idea. Beyond that, databases. Beyond that, the operating system itself. So it's covering the breadth of computer, not necessarily computer science, but certainly computer engineering. All of these things work together, and any one of them could take a lifetime of attention. Or you could try to learn a little bit and do it all. Oh, and if you are curious about what DevOps is, I didn't ask you. That's a portmanteau of development and operations. So this is kind of even a further discipline. This person will take all of this code, the database and the web server, and bring it all together. DevOps is something it's not super new, but it's an emerging field within web development, within development in general.
What's a pixel pusher?
Oh, a pixel pusher is kind of a derisive term. It's like the person who's, concerned with making the JPEG the exact same size and positioning it right on the screen. A good developer doesn't need to rely on these kind of things.
I used to listen to
You're still in good company here. All right. You might like this stuff a little bit better, though. At least I hope so. Oh, and QA, quality assurance. Usually as a capstone of all this stuff, I go on a rant about unit testing. That's all part of it. You have to write code to test your code. You guys don't do any of that stuff here because we have a chicken and an egg problem. You've never programmed. How are you going to write a program to test your code? Doesn't make any sense, right? So we don't get to really get into that. Okay, so the cloud, old idea. When I started university, 20 years ago, we didn't have desktop machines like we do now. We just had dumb terminals connected to a central server. That's the cloud. The cloud is just a marketing term. So at some point, I was in high school, everyone could start affording the Intel 486. All of a sudden, everyone got dial-up modem connections. Everyone, all that information that previously was stored in the cloud comes down to your location. So it kind of like rained down. Houses burned down, family photos are lost, valuable data. We got to store this stuff off site. It's a cycle, right? Because it was too expensive to have everyone have a computer. Everyone had a computer. It's great. More computers, more problems. Okay, let someone else deal with this data. Data's going to get stolen. Companies are going to go to business. I want the data at my house again, right? It just keeps going over and over again. So, old idea, new term. One I use all the time. I'm sure most of you do as well. Google Drive, Gmail. I use Heroku from time to time. Your stuff on someone else's computer. Version control, Git. So again, that relationship. What is Ruby to Sinatra? What is Ruby to Rails? What is SQL to SQLite? Git is a piece of software written by this guy here. Anyone heard of Linus Torvalds? Anyone heard of Linux? Linus wrote Linux. Linux is the open source version of an old proprietary operating system called Unix. This was, I believe, developed at either AT&T or Bell Labs. Computer science history is all corporate history. These guys wrote the C language to write Unix, which was sold like Microsoft Windows or Mac OS. And then this Linus guy came along, I think it was 1991. Oh, I guess it says 2005. That's not right. Oh, no, that's Git. Sorry. No, Linus wrote Linux in like 1991. Linux today is the operating system used on the web. Not without exception, but any serious high-tech company, certainly. Opinion, right? Very much an opinion. What's not mentioned in this intro to Git is that it was written out of spite by Linus Torvalds. And I just heard this story through Lighthouse Labs, actually, about 2 cycles ago. Apparently, they used to use a versioning control system called Bitbucket. There's a problem. They reverse engineered it. They said, hey, Bitbucket, we found something wrong with your software. They were immediately threatened to be sued. So Linus cuts all ties with this company, writes Git in the space of 3 days, and within 6 days, the Git software was versioning itself, like this weird Skynet Inception kind of thing, right? It's like this dream inside of a dream, and it's versioning itself.
Like from an artificial intelligence standpoint?
No, it's nothing like that. Shoot, it's just marked up tags, right? So you can track changes from the time a document was created till the end of its life cycle and go back and forth to any point you want. No AI involved in that. But so the software was managing the software. Okay, so 33% adoption. I think that's very conservative. The good, very powerful. I use it all the time. Huge community behind it. Even if you don't want to go into development in any capacity, I've never understood why, like writers and people who have to be creative with their words, why they don't use Git. It's not just for software. You can. It's not so good with binary files like images, but with plain text files, it's. I don't know where I'd be without it. Actually, it's amazing. It's very hard to learn. So what I hope to do today, and I'm definitely pushing it for time here, is just to create a Git repository on GitHub. So there's that relation. What is Git to GitHub? Git is open source software. Anyone can use it. According to the license, anyone can take it, write it, sell it, even if they didn't write it. GitHub sells that service. Free software. All right. So, oh, there you go. Look at that's the Octo cat. I think octopuses are neat. Kind of got mixed feelings about cats. But this is, yeah. Okay, so open versus closed source. These really should like kind of conceal because this is like a good time to ask questions. What's open source? I know, right? So yeah, open source was created by a guy named Richard Stallman in 1981. He wrote something called the GNU Public License. I hope I'm getting the dates right. But GNU stood for GNU is not Unix. And of course, that G stands for GNU is not Unix. So it's like this recursive acronym. And he was kind of like the early Linus Torvalds in that he was trying to write Unix programs, give them away for free. So he came up with this GNU license. And, you know, almost 40 years later, that's probably the one that's going to go first. It's very restrictive. I just want to somehow illustrate this point. Open source does not always mean what I just said. It doesn't mean that you can necessarily take it, revise it, and sell it. The GNU license is one of those licenses. So either you have to pay the developer, you have to get explicit permission, and usually under no case can you ever sell the software. Very restrictive, but open source license. The MIT license, named for the Massachusetts Institute of Technology, is probably one of the most permissive. All it says, there's no warranties associated with this. If you have a problem with it, it's your problem, but you are free to do with it whatever you want, and that includes rewriting it, selling it, packaging it as your own. Closed source, here's a question. Can you think of any closed source software? Just some examples.
Video games?
Video games are closed source. Photoshop, there's a big one. Adobe's almost always closed source. I can't think of any exceptions.
How do they protect the closed source like back end so other people can't access it?
Well, I mean that's a big question. So now it depends on what kind of application this is. So it sounds like you're talking in terms of a web application. So how do you prevent people from stealing your code?
Well, like a good example would be video games. Someone wants to open the code to see what certain things happen in the game, or if not. I mean, there's a way that you can access it, but how do they protect that from?
I don't think they
is
can.
The code just like if the code just runs, it's there, right? I mean, is it not?
You can use what's called a decompiler. So video games, it's been a long time since I've had any interest on the development side, but they're usually written in languages like C or C++, which are compiled languages. So when you're writing Ruby, you kind of have the text on the screen, and you give that text directly to what's called an interpreter. Software like a video game written in a lower level language like C, you'll have those words on the page, but you run it through what's called a compiler, which actually turns it down into all the ones and zeros that get fed through the CPU. So there's nothing you can do to stop decompiling, but it would take a great deal of effort to understand the symbols returned to you, right? Because as programmers, we can write notes to ourselves, we can give our variable names, descriptive names, we can give an idea of how we can do this or what we did in our software. If you're decompiling that, the functionality's there, but all the context, all those messages to yourself are not. So there you go. Does that sound? Yeah?
Yeah, it's just always.
Yeah. No, there's nothing you can do. And I mean, look at pirate software. I mean, if there was a way to protect it, I wouldn't see these Facebook ads, saying I should report my company. Okay, so some open source versus closed source. All the ones we like to use: Ruby, Linux, Firefox, Rails, and jQuery. Closed source. This one's no longer true. .NET is a Microsoft product. Microsoft is notoriously closed source. We've already named Adobe Photoshop. But, kind of getting with the times here, Microsoft has open sourced the .NET framework. So this is another framework you can use to build, well, basically any kind of application, enterprise applications, web applications. Yeah, it's in that sense, it's not unlike Rails. I've done a little bit of .NET. It's nice to see it's open source, actually. Okay, so where do we code? Cloud9. We'll talk about that. We don't really need to mention these because you guys are going to be doing your work exclusively in Cloud9. One thing I will mention, though, is that all this stuff comes down to words on paper or on your screen. You can just use an ordinary text editor. So if you use Windows, Notepad is fine. The one that's mentioned here, that's the one I use for everything. It's called Vim. Sublime is very popular with Mac users. It's also very good software. Just nicer ways to write your programs. Okay, so demo time. We're going to do Cloud9 first. C9.io. IO stands for Indian Ocean. It also stands for input output. So you'll see like a lot of, it's kind of trendy to have a .io domain. To do this, you need your GitHub account. If you haven't already signed up, it's going to give you that opportunity to sign up through GitHub. See, if I were to sign in now, it's just taking this email and this password from some other web page. It's not going to work. But if you click on this guy down here, it'll ask you to sign into GitHub and uses that as your authentication. These things work pretty closely together, so that's the recommended avenue I would take. So, first thing I want to do, I know this is a little bit big, yours might be a little bit nicer spread on the screen, but you can see I've got just a whole bunch of different workspaces from past courses and all this kind of stuff. I haven't hit that upper limit, so you guys are pretty much free to experiment with this. Mess it up really bad, delete it, it doesn't matter. You can have as many of these workspaces as you want. So I'm going to create a brand new workspace. And I will call it, what is it, September week 1. Give it a descriptive name. So I called it September week 1. I wanted day 1. Demo for week 1, day 1, just like that. So once you do this, you get a bunch of different options, different templates, or you can clone from Git. So this is why you're going to want to push all your stuff to Git when you get the opportunity. I'll go nice and slow when it comes to that time, and you guys can try to follow along as best. But I will send out a summary that you'll receive in your email as well. Or, of course, you can also watch the video. So we're not going to clone anything, but we have all these different templates. You guys are probably familiar with Rails. Oh, mine's off the screen, but there's Ruby on Rails. You got your Node.js. This is very hot technology right now. If you want to get started with WordPress, why not? Give it a try. Doesn't cost you anything. Just click one. I'm just going to click the basic HTML5 workspace like that. It's going to take a little bit of time. So what this is doing, it's loading an integrated development environment, IDE. So if I say IDE, I mean integrated development environment. This takes that text editor. It takes your command line, as though you're working with Linux, gives you a nice file tree, and it gives you a whole bunch of nice stuff like different types of servers. If you want to create, if you want to try out an Apache server, you want to try out a Node server, whatever you want, it's in there. So it opens up I know my screen's a little bit big here. Let me just shrink that down a bit. Okay, so here are the three main components. This is where you do all your programming. Here, I'll bring up a better one. So here's a Hello World HTML page, and this is just something that they put in there to give you inspiration. You'll see a little bit of CSS, a little bit of JavaScript, all within the structure of an HTML document. So this is where you make all your changes, you create new programs, create new files for within the Sinatra framework, or you create your web page content. Down here on the bottom, this is the command line. This is how you interact with Linux. The joke was when I was going through my last round of university that, because I would TA Python programming, the joke was that, you know, kids can't type, you know, that was always like the lament. None of these kids can type. The joke was that eventually they're not even going to be using a mouse. You won't know how to use it. The command line interface has been with us since day one. It's never going anywhere. It's a good idea to have a kind of a rudimentary idea of how it works. So a lot of your work, cloning, building your environment, takes place down here on your Linux interface. On the other side here, just your file structure. So when you start on Finstagram, it's going to be a lot more complex with a lot more folders. But right now, we've got a very simple web page and a README file. It just tells you, okay, well, hi there. This is the first time you've created a workspace. You want to try it out, run the server. So let's do that. This is one of these really nice things about Cloud9. So if I go to run, and I can choose from all these different options. The simplest one, this is probably still the world's most popular web server, Apache. So I'm just going to serve up this simple web page with Apache. So you'll see a little bit of output. This is the server telling me what it's doing. So every time I make a request, it's going to log that, and it's going to output it to console. This is very useful for debugging. When you hit an error, you got a crazy long stack trace. There's no shame in that. It happens all the time. That's the first place you look to find a problem. But that's for another day. So let's see what it actually looks like. This is just the thing out of the box. I can open it up. Okay, it gives me a button. It says, click me. Hello World. Hello World is the traditional first program for new programmers like yourself. So you're going to see me do that all the time. If you click it again, nothing happens. So this is just CSS, JavaScript, and HTML. Here's the CSS part. You guys are going to get a lot more sophisticated in how you construct these pages as you go through this course. Okay, so now this is kind of the heart of what we want to do. You guys have seen how to do it. You've got until Monday. If you want something to do, go around and play with it. Try it. Fire up the WordPress one, you know. See how that works for you. My wife does a lot of stuff in WordPress, so I'm quite familiar with it. It's old software, but it's good software. Okay, so let's go back to GitHub. So the way you do this is going to be different depending on the situation. So I've created a project in this case, and I just want some way to bring it into version control. I want to be able to work on it in Cloud9. When I'm happy with the changes I've made, I want to lock in that commitment and push it back to GitHub so that other people can look at it, so that I can download it onto another computer, whatever the case may be. So I'm going to go, whoops, not that one. I totally skipped over the selection that I wanted. And you're going to see me fumble like this all the time. It would be like watching your grandma use a computer. All right. So first thing I'm going to do is I'm going to create a new repository. So each one of these is called a repository. All different pieces of software. New repository. I want to name it the same thing just so it keeps in line. What did I call it? Not that guy. I called it September 1 Day 1 Demo. All right. September, week 1, day 1 demo. Give it a description. So this is very familiar. You're kind of just repeating the work that you did at Cloud9 for week 1, day 1, September 2016. All right. This is where it's going to get a little bit tricky. So now you're presented with this opportunity. And really, this is kind of the way you should do it, but it's not always the way it's going to happen, because I have this problem. I want to get all this stuff onto GitHub. If I had just had the foresight to initialize the repository with a README file, which typically contains, user instructions or developer instructions, I could create that repository, clone that README file, and get to work. Can't do it in this case. You'll find that this happens. So I'm going to recreate the repository. And it's going to say, well, it doesn't have any content here. You got to provide it. And it is very helpful in doing this. So this is going to be at least your introduction, or at least, witnessing how to use the command line if you haven't done that before. So the one that we probably want is this guy down here. So if you're following along, you can pretty much skip all this stuff. Don't worry about that. Go to the header that says, or push an existing repository from the command line. GitHub's being very helpful here. All you need to do is copy and paste this. So observe, Control C. I come back to my Cloud9 environment. Uh-oh, where am I? Oh yes, of course. I'm looking at the server output. I need to get back to my command line, which is right here. You can always create as many of these as you want as well, so you're never really going to lose it. So I paste that in there. I hit enter. Whoops. Oh, I just botched that. You see what I did? There we go. Oh, no. Okay, I forgot something. I actually, honestly, forgot something. All right. First thing I got to do. Right now, this isn't a Git repository. There's nothing in here indicating that these files are under version control. What I need to do first is type in git space init.
Will that dollar sign already be there?
The dollar sign is what's called the prompt. So yes, the dollar sign will be there. You do not enter the dollar sign onto the command line. It just says, I'm waiting for instructions. Give me the command. So Git's just a program like any other. This is how you interface with the command line. I type in git. Okay, what do I want to do with git? I want to initialize. I hit enter. Program executes. You're going to notice a little bit of a difference. So this is the contents of my directory. Here's that README. It's up here. Here's that hello world.html files up here. There's an invisible one called C9. That's just some Cloud9 configuration. By running git init, now I've got this magical little directory folder. So if you were using the File Explorer, or what I'm not sure what you call it in Mac, you double click on the folder, shows you the contents. So when you're using the command line, you use much more primitive commands. ls just lists the files in there. Okay, sees README, sees hello world minus HTML. ls space minus L gives me a little bit more information. How big are these files? Oh, this one's 907 bytes. This one's 1,272 bytes. I need a little bit more information. ls space minus AL. It gives me those two hidden directories. It's not hidden because there's anything secret in there. They're just hidden because it's cluttered. So that's a Linux. You put a dot before the name, it's hidden when you try to look at it. Okay. Few little things, this is just information that's added on. So what I've done now, oops, oh, I still haven't done that. What I have to do now that I have that Git repository, and hopefully I haven't lost anyone with my ramblings here, I have to paste that command I just took from GitHub. Remember that git remote add origin. So this is the same program. It's saying, okay, I need a remote address. I need to send this somewhere. I'm going to add a remote, because you can have as many. GitHub's just one. I use a lot of GitHub. I use a lot of private repositories. I can push them wherever I need to. So that's a new one. I call it origin, because this is how I'm going to kind of treat the GitHub repository. This is the master. All the stuff there is authoritative. And then I give it that address, that URL. September week 1, day 1 demo. I press enter, and I type in this git remote -v again. There it is. Before it was blank. Now it's there. Okay, so now we have version control. We have an origin repository, or a host repository over here at GitHub. But we don't have anything tracked. It's ready to track your files, but we haven't tracked anything just yet. So if I type in git space status and press enter, it's going to tell me a few things. I'm going to make this a little bit bigger so it's easier to see. So this is where I typed in git status. I'm on the master branch. I haven't committed anything. That's why it says initial commit. And it says I've got 2 untracked files. Well, these are pretty much the whole heart of my project here. So I better bring these into version control. I'm going to show you the long way to do it just so you have a very clear understanding. I say git add readme. And I check my status again. Oh, okay. So, readme is ready to be committed. Changes still haven't been written to disk yet, or at least they're not fully tracked by Git. So I want to add this other one though. I want to say git add hello world. Do git status. Okay, no more red files. Git knows about readme.md. It knows about hello world.html. It says, okay, well, I'm waiting for you to do something with these. I'm happy with the work I've done, and I'm going to commit. Git commit -m, my first commit. The idea, actually, I should show you good practices here. You always talk when you're making Git messages, and this is kind of a workplace thing, so you can do it like the pros do it. You always talk in terms of what's going to happen if you pull this recent commit. So I say get my new project. So anyone who comes and looks at this, they read this commit and they say, okay, I can go get Dan's new project. So you always talk in that active sense. Not sure why, that's just the convention that's developed. Okay, so I do git status again. Oh, some different stuff has happened. Okay, so 2 files changed. Basically just added everything. No changes, no nothing, okay. On branch master, okay, nothing to commit. Okay, so now this is where I'm ready to send it to GitHub. Now, just for a refresher, this is what it looks like now. Uh-oh, what happened? It's coming back. There it goes. All right, so this is what it looks like now. There's no information in there. It's just instructions on how to set up your project. So if I come back to Cloud 9, I say git push. I want to give the origin my master copy here. So I do that. Bam. Uh-oh. Oops, I misspelled origin. You see that? This happens all the time. There we go. Log in with your credentials. And a lot of times people look and they say, oh, it's not coming up. That's just so that no one can read it. So when you're typing in here, your computer hasn't frozen. It's just that your password's being protected from, prying eyes. So I was explaining that, and I didn't type in my password correctly. Hang on. Let's try that again.
That sounds so serious. Fatal.
Yeah. No screwing around. Oh, there it goes. Okay, it's sent. And if you have any doubts about this, now I come back to GitHub. I press refresh, and now I have that actual content. So this is an exact copy of the information that I just committed to the database. And now anyone can come along and check out what I did, how I built my Hello World page. So most development in web development is open source. There's very little sense in keeping secrets. And that's all it is. Okay, so Getting way over my time, but I want to show you one more thing. So we're actually going to change the code, change how it behaves, and then commit it one more time. And I know this is like, you're looking at this and it's like, I'm never going to remember that. I'm just writing on my notepad and all this kind of stuff. I'll send this to you all in a lecture summary. So you'll be able to do this and refer to it and just get the process down.
Which specific words are you using? Like you use remote status, commit, push order. Like how do you know what?
Time, repetition, brute force repetition. And I have to stress this. There's just going to be so many things, just new words, new concepts, and don't be shy. Like it takes forever. And if you feel behind, you're not behind because everyone else is behind as well. So, yeah, take heart. You'll do fine. Okay. All right, so we're just going to make a couple little changes. Let's see what we got.
So that right there is HTML.
Well, okay. Well, this is actually for next Monday, but we can go over a little bit now because, again, repetition does not hurt. And when I ask questions next time, you're going to be saying, oh, yeah, I remember that from last day. So there's no reason why you have to divide these up into multiple files. What we have here is clearly for demo purposes. You don't usually do it this way. But this is an HTML document. As part of this document, we're setting styles in line as part of a page. Usually we don't do this. Usually we separate all these different interests into different files, and then we tell the server, okay, when someone requests this page, just send all this stuff with it. This all comes down in one big bundle here. So these are the styles applied. Well, this is main content. Here's the button style. Let's see what it looks like. Okay, so I can change this around. Let's just change it to something dramatic. I'll change it to red. Are you guys familiar with this kind? Whoops. Are you familiar with these hexadecimal digits? Sometimes people are aware of like the FF00. Anyone tell me what that means? So this is a color. Of course, we will get into this more. These are hexadecimal digits. So we count from 0 to 9. Then we run out of digits. Then we go 10, 11, 12. When you're talking about hexadecimal, we count from 0 to 9. And since there's 16 digits in this counting system, we need to start borrowing from the alphabet. So 0, 9, A, B, C, D, E, F, which is 15 in decimal. This number here is grouped into 3 color concentrations. So the first 2 digits, the FF, is full red. The next one, these 2 digits are the concentration of green, and these 2 digits are the concentration of blue. So now if I change this, very subtle change. I hope okay, so currently it turns to white, or this kind of beigey color. I refresh my browser because the front end still doesn't know that I made changes to the code. I've got to make a new request to the browser, press refresh, and get that new program in, or the new web page. Now, when I hover over it, now it's red, right? So, if you mix all these colors together, so like we could take this guy out, make it all blue. Same kind of thing, I test it, and this is kind of what you do when you start developing. You make these small changes, and then you try them out, make sure they work. So now it's blue. You can, of course, what I found, and I don't know why, because I don't really know anything about color theory, but if you do these repeat patterns, say if you did I don't know, D3, 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 you always get varying shades of gray. I don't know. So you can get dark gray and light gray. Yeah. So you mix them all. I think that came back. Yeah, so it's kind of that weird gray color, right? Okay, any questions about that? So that's your intro to CSS. So down here, this is kind of the main content. You're going to see where you have that click me. That's the content of the button. Now, don't click me. Who can resist? And then it says down here. So now this just acts the same way. So I just made a very subtle change. When I click, it says click me currently. But now when I refresh, now it says don't click me. So I think it only makes sense that something dreadful should happen. Currently, now this is the JavaScript. You can kind of see where these things are broken down. It's not really the way we do things, but it's legitimate nonetheless. So we define styles, our CSS up here, up at the top of the document or in the head of the document. And we defined some executable stuff down here in the script. So that's JavaScript. This, of course, is that language that executes on the client side. We can make just a couple superficial changes. Whoops. There we go. It's kind of hard type or standing up to type. All right, kaboom. There we go. So some very superficial changes, but okay. Oh, it says don't click it. Better not click it. Oh, kaboom. All right, there we go. All right. Very cursory introduction to what you're going to be doing on Monday. Here's what really matters. Now we have some changes. We looked at GitHub. Well, this is the old stuff, right? The color is still the same. Still says click me. Still says hello world. We changed our program. It does different things now. So now we have to push these changes to the repository. That's not the one I want. There we go. So if I type in that git status again, oh, okay, it tells me something changed here. Hello world is different from what it used to be. If I'm not sure what I did, I can use this command, git diff for difference. Okay, so I changed the background color. Yeah, okay, don't click me. Oh, yeah. There you go, kaboom. So something's changed. The changes are not yet being tracked. To do this, I have to add and then commit. So I add hello world. Watch how it changes. Now it's green. Okay. This thing's ready to be tagged. It's ready to be committed. This is called staging. So I say git commit, and I give it that little -m so I can just write a message to myself. Get new button, I guess. I don't know. Remember, talking in that active sense, right? If you download this, you pull this change, this is what you're doing. I'm getting the new button. All right, still there. It's being tracked now. I can go and I can do some more work, make new commits, do whatever I want. But what I like to do is I like to make these commits very frequently. Anytime there's like, any sort of even small change, I leave a little message to myself and then I push it somewhere else so that I don't lose it. Git push. Now, before I had to do this, and you can still do this, origin master. Since I already did it once, it just assumes that that's the one I'm always going to be doing, right or wrong, so I can just take a shortcut. And there it goes. All right, so if you're in the nervous type, you can go back here to git. Oh, I didn't leave my changes up, but now if I look at my hello world, that was the old commit. Now, if I look down in my code, where did I change? Oh, kaboom. There's like the best evidence right there. So kaboom. If you really kind of want to see the history, you can do this forever and ever. It's just going to keep track of those changes until you either reset it or clear out all that data. There's no reason to do that.
Is there
Not that I'm aware of. That's a good question, though. I think it's really just limited by the size of your file system. Because obviously, I mean, if you keep making commits and you make a bigger and bigger project, every change you made, even the deletions are going to be there. So it's just going to get bigger and bigger and bigger until you run out of disk space. So.
Why can't you delete the first files and leave the
It will still be there, yes.
parameters?
If you roll back. So you're not going to do this every single day, right? But yes, once it's under version control, if, for example, that's a good question. Well, here's another quick little lesson. Usually when you're creating a web page, your landing page, the one that when you type in your URL, the landing page is always named index because that's the first one it looks for. So if I rename this to index, effectively in the mind of Git over here, it's going to tell you something. Oh, I deleted hello world, but now there's this new file. So let's change it. Git add. That's a shortcut. So I showed you the long way. Now I'm using that -A. I'm just going to add everything at once. It's a little bit faster, of course. Git status. All right, so it's actually pretty smart. It says it renamed it to that, but depends. Right, so now I say, okay, git commit -m. Whoops. Sorry, back up a second. Git commit -m for message. Rename hello world to index.html. All right, git status. Git status, of course, doesn't actually change anything. It's just showing you the current status of your repository. Git push. Whoops. All right, so now when I come to my GitHub, I no longer have that, no longer have hello world. I wonder if, yeah, but I could like pull from this commit and get it before that index was deleted. So it's always kind of there to be aware of. Okay, I think, let me just check. Got a couple more slides. Nope, we did demo. Any questions? Yeah, I bet. And that was me, man. Sometimes I can't even tell because sometimes you guys come in here and it's like, oh yes, we know what like HTTP is and all that kind of stuff.
Can you explain the windows in Cloud 9?
Yeah.
Oh yes, of course.
Because there's different, I wasn't sure which one was which.
Okay. So this is your integrated development environment. This one is effectively just a text editor. That's the one my cursor's over right now. So this is where you write all your programs. If you need to say add a file, let's say this is your file tree, you can, it kind of works the same way you'd expect, say on a Mac or on a Windows machine. I just right click there and I can say make a new file.
Is that little tab always called bash?
Yes. Bash stands for born again shell. There's all sorts of different shells. The Born shell, the Corn shell, C shell. This is all like Linux operating system history. So what I just did there, this is where, for example, maybe I want to just make a really quick hello page here. And I'll whip up a really quick website. Maybe. HTML. You're going to see me do this all on Monday as well. But these are the basic components: head and body. Doesn't hurt to get a little bit of an introduction, so I'm just going to say hello world. And if I go to my server, of course, I don't have any sort of way to link to that, but if I just type in the URL manually, now it gives me that page right there. So I just made a little web page. Okay.
So you're calling this an integrated what?
Integrated Development Environment, or IDE for short. And there's lots of different ones. This one is a cloud-based IDE. And it's actually really great. So now down here, this is the bash shell. Right there, you can see bash if you're wondering where that came from. This is your interface to the Linux operating system. So when you created a workspace, you actually got a neat little virtual machine somewhere in some server, somewhere off in the cloud. And you were allocated these resources. And they're pretty meager, to be sure. You get like 2 gigabytes of storage, 512 megabytes of RAM. So not a lot of power, but usually sufficient for projects like these, and certainly sufficient for an application as sophisticated as Finstagram, because it is actually really quite really quite a good project. So 3 basic components, and you'll be using your time. Your time will kind of split between here mostly and here, I suspect, between the text editor where you write your programs and the command line where you make your git commits, your pushes, you build your environment, you manage your different dependencies.
What does that mean?
Dependency?
Well, no, just so you write the code there, and then like I don't understand what the bottom is.
Okay, so this is like if you booted up your machine. What kind of machine you got there?
A Mac.
So there is actually a similar terminal interface. Mac OS is built on a variant of Unix called BSD, Berkeley Systems Development or something. I'm not sure what it is. But it's a proprietary operating system like Unix. And at the core of it, this is how you interact with your machine. So if you opened up a terminal, you would see a shell very similar to this. So while you're used to using your mouse pad, double-clicking on the file explorer or whatever it is, this is the way we did it before mouses or mice. I'm never really sure, like computer mice. The plurals to me always, I don't know, always stuck in my head as mouses. But you can look inside your directories. You can create new files. So if I do, watch what happens when I press enter, you're going to see a file appear here. There's world.html. So 3 components. I'm not sure that addressed your question. How do these interact with each
So
other?
I was just trying to like get in my mind like what does it mean, right? Like that top one is code, right?
Yep.
Or you write whatever. But then what are you doing down below, and how like what does it mean?
Okay, so this is what's called the command prompt. The best analogy I can draw is like double clicking on a piece of software, say on your taskbar, or opening up a document for editing, say like in Word or something like that. The only difference here is that traditionally, and if you're working in a server environment remotely, you don't have a nice window to work with. What this means is that to use this, you're bypassing all the nice elements of the Windows system that you're used to. This is just a new way to interact with your computer. And you, in fact, as a Mac user, can do it this exact same way. Everything that I've done up here. So, CLI, command line interface, instead of a graphical user interface, instead of using the mouse, it's just keyboard, press enter, execute.
So the code prompt on the bottom, is that working like to communicate to Git?
Yes.
And is that its primary function?
No, this is the entire operating system.
So why is there 2 code windows?
These multiple windows,
Well,
these are all for code.
You can write code in the top and the
Yes.
bottom, that gray and the black?
No, this is for executing programs. This is for viewing what's happening on your server, for example. For your purposes, it's going to be mostly version control with Git and for deploying to Heroku. So when you have something you're ready to show off, then you push it to Heroku, and then everyone can come and look at it.
So
It's like
basically, it's the
the
difference between like
manual.
saying save as.
Exactly.
That's what that's doing, right?
Kind of. But I mean, maybe this is kind of a mixed bag. That's right. But yeah, you can do all that kind of different stuff, right? So this is probably the interface that you're most familiar with. You have your traditional file, edit, find, all this kind of stuff. This is, I guess, the historic way, but it's not historic. People do it this way because it's faster.
Do you also get more functionality like further down the road? You're like able to do more things because you're doing it that way as opposed to.
Yes, and in terms of professional web development, this is, if you want, you need to know how to navigate a Linux system, operating system.
And that's what that is. Just
Yes.
Linux inside Cloud.
Yes, exactly. This is a full-fledged Linux operating system somewhere on some virtual machine, who knows where.
So, if I'm, let's say, traveling and I don't have access to the internet, and I want to use a text editor, command line, or command on the computer, I can transfer those files.
Yes. Transfer them from Cloud9 without an
No,
internet
from my
connection?
computer to the cloud, because if I don't have access to the internet, traveling, I want to use text editor, command line, code, and then come back online.
Yes, you certainly could do that. Question?
So like you only had hello when you opened your page, it was only a couple things, but would someone like more experienced, like would they write everything in the top coding box and then push it to Git, or would they kind of, because like you only had a couple things in it when you pushed it to Git to look at it, but would some programmers like not push it until they had like more stuff?
I'm not saying this for laughs, but no, not a professional developer. With the idea with Git, it is pretty lightweight. I mean, there's always that risk that you're going to fill your disk, but no, make really frequent commits. So make one file or even one change inside a file, make a commit. That's not to say you guys have to be so obsessive about it. I mean, this is relatively trivial. It's not mission critical systems here, but it's a good habit to get into. And I think this is, if anything, you're going to take away. I just started introducing this early on because by the last day, I was like, oh, what do I do now? Git commit what? Git status? This doesn't make any sense, right? So now you get to see it first day, and you're going to get comfortable with it. And it's just going to be just from repetition. You're going to know how to use it. Any other questions?
Git is just one option of this integrated development. Right? There's other options, or
So Git is one of many tools, and it serves one specific function: version control. So maybe you're not using it to write programs. Maybe maybe you're writing a novel. You write down chapter 1, you commit, you push it to GitHub. You come back to work, write down chapter 2, commit, push it to GitHub. It's just storage, version controlled storage. Yes. These are good questions. Keep them coming. Okay, well, if that is that, I know Jen has some plans for us.
usually you finish at
8:30. Goodness gracious.